Okay, we'll go through evaluating a definite integral using the substitution, and we'll show the two different ways. One way he shows on the videos, and then this other way. If we have definite integral from 0 to 2 of x times the quantity x squared minus 4 to the 5th power dx. Okay. Now, the straightforward way, we look at the antiderivative, and we're going to let u equal what? Okay, the inside x squared minus 4. Du will equal what? 2x. Okay, 2x dx. Now, I'll also show you the alternative way that I showed you earlier with the antiderivative. At this point, he basically looks at, we have x dx, and what do we need to make it the rest of it. But what more students like to do is go ahead and solve this for dx. We'd have du over 2x. And then plugging in everything, we've got the x times, well, this would be u to the 5th, and then dx would be du over 2x. And using the antiderivative technique this way, substitution, we've got the x divided by x. Now, don't lose this little 2 underneath there. That's still part of the antiderivative. So we'd have 1/2 times the antiderivative of u to the 5th du. Okay. So that's kind of an alternate way of finding the antiderivative. And now, when we find the antiderivative, we do what? We'll get u to the 6th over 6. Okay. And technically, if we're only looking for the antiderivative, we'd put plus c, and then resubstituting, we'd end up with 1/2, or, well, let's go ahead and multiply 1/12, 2 times 6 in the denominator. So 1/12, and then u to the 6th. Well, u is that to the 6th plus c. Now, in this problem, we're not just finding the antiderivative, but we need to evaluate the definite integral from 0 to 2. So let's take that to the next page. So integrating from 0 to 2, instead of having that plus c on there, we'll have this, and then we can plug in the 2. 2 squared minus 4 to the 6th. Then minus, plug in the 0. And here's a case where plugging in 0, we do not get 0 for that part. So be careful. Okay. And what we end up with, well, actually, this part turns out to be 0. So we'd have a negative 1/12 times, well, negative 4 to the 6th power. Negative raised to a even exponent will give us a positive, and 4 to the 6th is what? Somebody help me out with that. Can't quite do that one in my head.
341. 341.
4 to the 6th.
It was 4. That's negative.
So 4,096, and then
It was a negative.
actually, no, it will be a positive. You plug this into your calculator, it's going to take the 6th power of 4 and then apply the negative to it. What you need to do is this.
Is that what it is? Oh, it's 4. Yeah,
Yeah.
it is.
So this is not true. This is true.
I was wondering why.
The calculator is programmed by order of operations, and this is saying do your exponent first, then apply the negative. But in this particular problem, we want -4 quantity to the 6th power.
That's crazy.
Okay, so the 4096 and then times the -1/12, we end up with negative what?
341.3.
Okay, so 355, and is it the 5's repeating? So,
No, I got it. No,
okay, so
we can calculate it now, and then I guess.
yeah, that's not what I want. Oh, this thing's not going to allow me to. Okay, that's wrong. Okay, is that the right answer? Okay, now this is how Professor Berger explains it. Okay, we go through the substitution, we resubstitute our x squared minus 4, and then the integration limits are actually when x equals 0 to x equals 2. Okay, so we plug in that. Now, the alternative way, I guess we'll start over, but we've done most of the work already. Okay, so again, the setup here, pretty much the same thing until we get to rewriting our integral limits. Now we'll go ahead and go through all this, and the x's would cancel. Now, one thing we have to keep in mind, we have substituted everything into terms of u except for the integral limits. And this other technique, we can go directly to terms of u from this point if we want to, but we have to plug that into u equals x squared minus 4. So what we had found in terms of u, we had the 1/2 u to the 5th du, but we didn't put integral limits in there because we haven't changed those to terms of u. If x is 0, what's u equal to? Okay, we substitute 0 in for x, and u will be -4. So now we're changing everything into terms of u. We won't have to go back to the x squared minus 4 plugged in after we integrate. So if x equals 2, what's u?
0.
Okay. So instead of going from x equals 0 to x equals 2, the definite integral, we're changing to u equals -4 to u equals 0. And let's do the integration then. 1/2 integrate, we still get our u to the 6th over 6th. But this time, we're going to leave it in terms of u. We're going to evaluate this from u equals -4 up to u equals 0. And we'd have our 1/12, and then we'd have 0 to the 6th minus -4 to the 6th. Well, that's exactly what we ended up calculating before, but before we had resubstituted x squared minus 4 in for u, and then went from x equals 0 to x equals 2. We get exactly the same thing whether we change it terms of u or terms of x, and we still get our negative 4096 times the 1/12, or the negative, what was it,
41.
Yeah, 341.3. Continuous.
Okay. So we get the same answer, it's just a little different way to go. And which way's right? Well, both of them are right. Which way do you need to do? Whichever way makes the most sense to you. This is one of those, one way isn't any better than the other. It's what you want to do, what makes the most sense for you. And over the years, there's been about half and half. Half of the students like this way, half of the students like the other way. Doesn't matter to me. Just want to show you the alternative way of doing definite integrals using substitution.